Hello, everybody. Thank you for joining us today. You are part of the 300 people worldwide who have registered to view this webcast powered by Yole Développement. My name is Camille Verrier, and I am Marketing and Communication Project Manager for Yole Développement. Power amplifier modules are key to any RF system. To address an increasing demand for spectral and power efficiency, innovative solutions are being deployed, including GaN and advanced filter technologies. Based on Yole Développement's most recent analysis and System Plus Consulting latest teardowns, the Yole group of companies offers an in-depth assessment of the technology and market trends affecting the RF PA and filter industries. Today, there will be 3 speakers from Yole Développement and System Plus Consulting to discuss these topics. Do not hesitate to ask questions using the Q&A button, as we will have a Q&A session at the end of the webcast. First, let's start with a global RF industry introduction presented by Claire Troadec. She is the activity leader for RF at Yole. Claire, the floor is yours.
Okay, thank you, Camille. Good morning, everyone. So it's a pleasure to be here, and I will start by a small introduction on this RF industry. So my name is Claire Troadec, and I'm indeed leading the RF activity within the company. So we could start with a very simple exercise. So really looking at the major M&A and joint venture in the RF industry in the past 3 years. So you have quite let's say, a vast roadmap here, or vast timeline here shown. So it's a very interesting exercise because if we would do this exercise and looking in the years much before 2013, you would see a less crowded spot. And here, so on purpose, so we represented the major M&A and joint ventures since 2013, and you can see, and I guess you're all aware of the very high dynamism we've seen since these years. So why is that? So one of the answers, of course, is the 4G LTE deployment. So this started in 2010, sorry. So as soon as we observed the first maturation of this LTE technology, we've seen a very high dynamism in the industry players. In fact, everyone nowadays, with the increased complexity of this 4G technology, meaning mainly due to the carrier aggregation, extended usage, so we have to deal with different frequencies that are used to transport signals. So before, in fact, every company was focusing on one kind of devices, and the components were mainly discrete. But nowadays, with this increased complexity, we've seen a race for companies to access the major building blocks in the RF industry. So this is why, for example, we've seen this very big merge between TriQuint RFMD in 2014, TriQuint being very much into filters, into power amplifier transceivers, RFMD, a very strong leader in antenna tuners, switches. So of course, this big Corvo group is now a giant with 2 very big companies before. You also see Murata acquiring Peregrine, so to have an integrated all RF front-end CMOS, for example. Avago Broadcom, of course, another big giant. Qualcomm acquiring or making a joint venture with TDK to have access to RF filters for fully integrated systems. So as I mentioned, a very high dynamism observed these past 3 years, and mainly due to this 4G deployment LTE standards. So another exercise that we can do is really looking at the cellular standards evolution. So if we start, so again, this is a chart I took from Soitec. It's a very simple picture. So you see the cellular standards evolution, so the mobile generation, so 2G, 3G, 4G, 5G, and next. And the different standards you have at different locations, so here represented in Japan, in Europe, or in US. So a very simple observation we can do, so we can see in the past that for each mobile generation, we had different standards related, so depending on your geographical location. So And with the increase of the channel bandwidth, so with the latest generation, so we have an increase in the channel bandwidth, meaning an increase of the quantity of information, the data speed, which can be delivered to the terminals. So we've seen now that we have less and less standards, so it's more an aggregation or a concentration of standards with time passing by. With here, for example, the 3.9G being mentioned and the starting of the carrier aggregation, meaning these higher peak data rates, and to facilitate the efficient use of the fragmented spectrum. Another observation, so we've seen some of the standards which are progressively being abandoned with the WiMAX 2. Of course, this is mainly due to competition. So we had at one point very high demand and maybe some kind of lack of infrastructure with the growing demand. So okay, competitive solution exists like the LTE Advanced, which is gaining more and more interest. So with 5G now, what can we expect? So that's the big question, because we can look at it with very different approaches. Before going into much details for this 5G, let's first have a look at the RF systems and what breakthrough could they give for the future. So we can see here a very simple schematic of a mobile radio, so a radio in a cell phone. So with the increased complexity, we see more and more pressure being put on the front-end module, of course, very close to the antenna, to the reception path. We here have the three big different blocks with the front-end module, the RF transceiver, and the model digital baseband processor, or baseband and application processor. And we represented the various technologies that you can see for these different blocks. So we all know for the front-end modules, so the power amplifier is a big building block, and gallium arsenide is the main technology being used today. We can also see, of course, some high-performance silicon germanium power amplifiers. And again, we can see different technologies depending at which look we take. RF-SOI being a technology that you can find also, of course, mainly in the baseband processors. So depending on the needs, of course, you would find different technologies. So now, what would 5G change? What could it mean? So just before looking at the technology changes, so what does 5G promises to deliver? So here, of course, you have a very well-known chart shown by Global Foundries, so really showing the main advantages that you expect by 5G compared to the 4G mobile generation. So it's all about, of course, very short latency, very high peak data rates, very high cell spectral efficiency, mobility, and well, cost. Well, it would be nice if it would follow the same way, the same path, but it might, of course, occur. This increased complexity would come with associated costs. But 5G is all about the broadband user experience. So you have different scenarios. So here, this is the scenario where 5G would be a very disruptive technology, a revolutionary, in fact, in the RF landscape. But if you look at facts, an incremental scenario would sound more rational, meaning an evolutionary path for cellular. 4G is still quite recent, so there is a need to get return on investment to still make profits for the users. So there is room for the evolution of 4G technology, which will progressively go to higher frequencies. So in fact, there are three scenarios for the 5G. So a usage where you would transition and go to higher frequencies, but still lower than 6 gigahertz. Higher frequencies around 28 gigahertz. This is more powered by Samsung, for example. and a very high, millimeter wave enabling technology if you are approaching the 56 or 60 gigahertz powered by Qualcomm. So today, just as a reminder, I mean, the maximum frequency used in cellular is less than 3 gigahertz, 2.6, 2.8 gigahertz. So of course, going to approaching, let's say, frequencies closer to 6 gigahertz would come with some major technology changes. So if we look at what would it mean, for example, for a standard front-end module, so again, here we have a very nice schematic being drawn by Soitec, and which is really showing the increased complexity that we can see with the evolution of the mobile generation. So here today, this represents the 4G, and there could still be some improvements made to the chart, but I'd say it's a good, simple approach. So again, we said 4G, carrier aggregation, okay, so we have more bands to handle. We say it's up to 43 different bands or 48 different bands compared to the previous UMTS or generation. So this comes with an increase in complexity, meaning that you have to have more filters, of course, to really fine-tune your signal. And you also need to put some efforts on your power amplifiers. So really, these advanced generations, these carrier aggregations, these increased frequencies put a lot of pressure on the power amplifier and on the filters. So this is why we have chosen these two subjects, which will be detailed later on by my colleagues, Chen and Stefan, to show you the various technologies and the needs for very robust technologies as we go to more increased complexity, in fact. So we have this pressure. We also can note that nowadays on the cell phones, we also have pressure on the power consumption. So on top of the performances, we put pressure on the power consumption. So this is why maybe other technologies of power amplifiers like RF GaN could help you also with the high power efficiency and the large spectrum, but of course there's also a cost trade-off to take into. But let's say that we need to be careful to be power-hungry elements as well. So if we go to the various technologies that could be used or that are being used from 2010 and make a projection to 2020, and we look at the various elements I just mentioned, so the power amplifiers being a very important building block, the filters, of course, being also very important building blocks. So we see various technologies. So we are all aware of the SAW technology being used to lower frequencies, the BO technologies being more robust or handling better the higher frequencies. So of course, those are the two major technologies. We've seen some nice improvements with the TC-SAW, like technologies by Murata, to go and approach the limits that we thought the SAW would approach to. So there's a very nice technologies and improvements happening there. On the power amplifier side, so mentioned gallium arsenide will remain the main technology. We've seen some SOI also because it has a size advantage over the others, and they are widely spread for making associated power amplifier plus switches and control circuitry, or to introduce power amplifier circuits over control circuits. But the CMOS power amplifier tend to grow in die size when the higher power is involved. So they might not be very appropriate for high integration. And something which is very funny also, if we look at the RF in a cellular, well, it's not the added value. So the space it has is very limited, and it has to cope with this space. So as this space is very limited, and maybe CMOS amplifier could go to bigger die sizes, there could be a penalty there, meaning that the gallium arsenide for equal performances would be a smaller die, so quite a battle on top of that. We can also consider hybrid power amplifiers, so hybrid technologies like gallium arsenide RF power amplifier with CMOS-made bias portions. That's one example. Another example, of course, comes from the MEMS industry. So we are always talking about these RF MEMS switches. So of course, it can have very nice, superb Q factor associated as demonstrated, for example, by Cavendish or Wispry. But once you integrate these switches in a module, well, the advantages of the RF MEMS itself is not so obvious because the system in the RF will always be limited by the cells. So as the alternatives like SOI are good enough compared to MEMS, and they have lower die size and lower cost, so this is why maybe we see the limited traction of the RF MEMS switches. Okay, so that's it for the examples. Maybe just to conclude the introduction, I just wanted to raise you the fact that, okay, RF is getting more and more important for the large volume applications. And given the high demand we have had from our customers on these areas, so we have decided to strengthen our RF activity from this year on. So we did in the past follow the RF market more for the high power applications in terms of market overview, and System Plus was also looking at the low power applications. But now we have a dedicated team to look from the low power to the high power amplification. So this is why we'll forecast the RF market demand, and we'll try to address it with the methodology we have in-house, meaning looking at the technology platforms, the devices, module, system levels. So this will be part of the exercise that we have started to strengthen from this year. And just to show you the report offer we have, so we started indeed with the RF GaN. So Chen will give you more example of this very exciting technology, which has been developed for defense applications in 1999, something like that, and which can be, of course, very interesting for more consumer-like applications. So we'll explain you how they can be used in consumer applications for base stations in the infrastructures. With our partner System Plus, so making very various front-end module analysis of filters. So Stefan is going to explain and give you more in-depth analysis of the existing solutions. And at the moment, so we're also working on a report to look at the RF components and modules for the cell phones, so really focusing on the front-end modules and the important components like the power amplifier, the filters, the switches, the antenna tuners, and markets, look at the market and the technology platforms. And we want to expand the various topics we'll look into by looking at the 5G impacts on the RF industry, from infrastructure to terminals, and also look at the RF for automotive, for example. So, okay, I think I took a little bit more time than I was planned to have, but okay. I hope this was interesting, and of course, if you have any topic of interest for your company, please let us know.
Thank you, Claire, for this very interesting introduction. Do not hesitate to ask questions using the Q&A button, as we will have the Q&A session right at the end of the webcast. So now let's continue with James Long's presentation. So he will discuss the GaN RF and his analysis for RF power electronics and compound semiconductors at Yole Développement. Chen?
Thank you, Camille. My name is Zheng Zhen, and I'm working on RF and compound semiconductor at Yole. We're glad to have this opportunity to share our research and observations on the GaN RF market. So I will begin with a brief introduction about GaN's benefits compared to existing technologies, then several GaN RF players, their products, the market size, and what will come in 5 years. Then I would like to give a special focus on wireless infrastructure as well as the coming development of 5G. Of course, for those who are perhaps not familiar with GaN technology, the first question perhaps is, why do we need GaN? And it is because compared to existing solutions, GaN can bring lots of benefits at system level. And from the material side, gallium nitride has higher electromobility than silicon and can operate at high frequency. It also has higher breakdown voltage, so lower system current and a lower loss. The higher power density helps also reduce the size and weight. So we can really have a smaller chip with higher power, high efficiency, and a larger bandwidth. And we see advantage from the hand structure those will bring lots of benefits to the overall RF system. GaN technology can be used in different components, but for now the main application of GaN RF focused on the power amplifier. And so as presented here, more than 15 years have passed since the first commercial GaN product is released. And we can see at first there were many American companies who were material supplier or traditional defense suppliers, because GaN was initially developed for military use, financed by the US government. Then around the year 2004, we see Japanese and European players enter this market. Near the year 2008, traditional RF player comes to this area. And with the development of WiMAX and LTE, more and more players comes, and a lot of products were released during this period. Also last week, we see Infineon announce the acquisition of Wolfspeed, and well, we are expecting to see how it will impact on the market. It should also be noted that all top three players in the RF power LDMOS area, they're NXP and Amplion for now, and Infineon, they all began releasing GaN products in the past 2 years. So it is a real sign that GaN is going to the mainstream, and we are waiting to see who is going to win this battle. And so here's an analysis of commercial available GaN RF product today. We can see that there's more than 13 companies covering from L to K bands, and from 1 watt until 1,000 watts. In terms of frequency range, for the time being, most players stops at K band, because for now there's no large market at high frequencies except some military suppliers and satellite applications. If we see from the targeting applications, GaN products are mainly used in wireless infrastructure, in military and special applications, and also in other markets such as cable television, SATCOM, VSAT, etc. Most players, they have related products, and they are trying to expand their portfolio in the wireless infrastructure markets. The real battlefield is near like 2 to 4 gigahertz, because the most used frequency for LTE is 1.9 to 2.6 gigahertz. And for other markets, different companies can have various strategies. For example, the US companies, they work more closely with the cable television companies to have those new kinds of products using GaN, while the Japanese companies, they are more focusing on the VSAT SATCOM products, because Japan is a big satellite TV market. In some of those applications today, gallium arsenide still holds the advantages of maturity, low cost, and still good linearity. It is for sure a strong competitor for GaN in those markets. But we believe as the cellular frequency goes higher and the implementation of new networks, there will be more and more GaN players go to high frequency and high power. So now let's talk about the market. This year, we estimate that the overall GaN RF market is near $300 million, in which the biggest two parts are wireless infrastructure and defense market. In our estimation, this total size will reach like more than 750 million, like that in around 2022, and they are mostly driven by these two big market segments. From the information that we have gathered, the defense market is no doubt steady growth for GaN, because it was originally developed for new generation phased array radars, and this technology goes more and more mature. We are quite confident about the increase of sales in defense parts. And then with the boost by the wireless part, the overall market should grow with a faster pace. And this two large parts of the market will decrease the price of GaN to a reasonable level and will then help penetrate into many other applications. For the cable television, the new standard, the DOCSIS 3.21, requires much higher power density that, from our feedback, that gallium arsenide begins to feel difficult. And for the RF energy, strong competition from the side of LDMOS, but we have still see some prototypes with GaN from some Asian manufacturers. So there's a lot of opportunities for GaN in the future, and we still see the wireless part stay as the biggest growth point. And so I would like to give a special focus on the wireless infrastructure because it is really important. The global connection number keeps going higher, and in order to meet this increasing data rates, we need a faster and more powerful network. GaN is really the key technology because it offers higher frequency, higher power, and better efficiency. The year 2014 and 15 was a fast development of LTE, especially in China. And during this massive implementation, some equipment suppliers begin using GaN, and the feedback is pretty good. GaN has already reached a considerable percentage and it keeps increasing. Also, for the coming upgrades in the cellular network for high frequency like 6 GHz and other features like the massive MIMO or carrier aggregations, GaN will be the best solution because LDMOS, they can hardly perform about 3.25 GHz, and gallium arsenide, they cannot support super high power level. We can say we are confident that GaN will gain more popularity in the coming years and take the share of LDMOS in this market. We are today on the way of pushing 5G development also, with LTE involved in parallel. The vision of the ITU is to promote a validated 5G standard near the year 2020, which should be during 3GPP release 16 or 17. There's already prototypes presented in different conferences, and some trial networks are undergoing. In Korea, they plan to test 5G network during the Winter Olympic Games in 2018, and the same for Japan, I think, in the 2020. So if it goes well, the first 5G network will begin around the year 2021, which is to say that GaN development pace should catch up with this timeline. In our ideal scenario, that GaN will keep increasing the penetration rates in those base stations and goes higher frequency to 6 GHz. And meanwhile, there will be more backhaul products entering millimeter wave range in the next 2 or 3 years in order to be well prepared when the 5G deployment begins. If that goes as what we planned during this period, during the rapid development phase between 2020 to 25, a large part of the implementation will be GaN. It will replace gradually LDMOS in the base stations because, again, LDMOS are not competitive at high frequencies, and GaN will compete with gallium arsenide in the backhaul solutions. With its good efficiency and broadband capability. In the future, GaN has the potential of taking near half of the share of the overall RF power market. When we analyze GaN RF products today, we found that it's the biggest market segment and have the most players. But if we look at today's products, most are focusing near the band of LTE, and we can see the potential is still big. With the new move to high frequencies and the coming 5G, there will be more and more GaN products. In our vision today, GaN RF industry is growing steadily. The good performance and simple design makes it easier to be adopted in different markets. one of the major barriers for GaN should be the price. In order to deal with that, well, on one hand, we are hoping that as more and more players arrive, we will see increased volume and eventually a decrease in device price. On the other hand, the existing players need to put more effort in the processor design to lower the cost. Early players who have been in this market for a while, it's sure they have some advantages compared to newcomers, and with the industry growth, they will no doubt increase their revenue. But the ranking today, we think, should change. And well, so for conclusion, we expect the majority to use LDMOS or gallium arsenide in the short term, but in the long term, GaN will be used most. The potential is big, and well, we are seeing more and more companies adopting GaN design, and many players interested in entering this market.
Thank you, Jen. We will continue and end this webcast with a presentation from Dr. Stéphane Elisabeth from System Plus Consulting with a focus on advanced filters. Stéphane?
Yeah. Hi, everyone. I'm Stéphane Elisabeth, cost engineer at System Plus Consulting. I'm in charge of RF and advanced packaging, and I will talk about advanced filter for consumer application, especially the reverse engineering and costing. So, to begin with, I will talk about the entire system RF we can find in a mobile phone. And this system that allows communication is actually composed by several blocks. All system has LNA to amplify the signal, diversity switch to provide communication on several frequency bands, antenna tuning to match the impedance of the antenna according to the frequency we work on, and filter to provide the best SNR on the selected frequency band. All systems are managed by that we call an RFIC, and depending of the constructor choice, all blocks of the diagram can be integrated in one module called FEM, Front End module. But several challenges occurs when we want to integrate all in one, like power dissipation, thermal management, electromagnetic interference. And my presentation will be focused on the filter, will represent almost 25% of the component cost, based on the cost decomposition of front-end modules from Broadcom that we can find on the Samsung Galaxy S set. So in the market of FEM, we can find several actors depending on the frequency band and the performance of the product, according to the seller and the buyer. However, we can find some specialty in the actor. Usually, Skyworks Solution and Murata works on the low band, whereas Broadcom and Qorvo are positioned in the mid and high band. So in fact, we have to cover the whole RF mobile spectrum to have a good smartphone today. And to do that, we have to use several technologies. According to a diagram made by Qorvo, we can see that the choice of the supplier is based on the complete smartphone design, the cost of the filter, and the performance required by the buyer. On different RF frequency, we can use even SAW filter or BAW filter. In some case, the SAW and the BAW filter can be competitive. So to continue, for the first point, the design specification can be a first choice of the buyer, For example, usually Qualcomm recommend to use Qorvo high-band FEM with its component because of the co-design between the two companies. And if we have a look on the two smartphones that we can find on the market. For example, the Apple use Skyworks, Broadcom, and Qorvo in its latest flagship, the iPhone 6s Plus. Skyworks for the low band, Avago for the mid band, and Qorvo for the high band. And there is one version of the smartphone for all around the world. Samsung use a different kind of marketing. We can find 3 different versions of the Galaxy S7 all around the world, and all 3 shows different FEM depending on the microprocessor. For example, in the USA and Southern Asia, we have a Qorvo for high band FEM because of the use of the Qualcomm Snapdragon 8020. But the European version uses the Samsung in-house processor, the Exynos 8, and so they use Broadcom FEM for high-band FEM. Of course, they could integrate the Qorvo's FEM, but here is the second criteria as the cost of the filter that became a decisive parameter. So, and the third criteria that is important is the performance that we want to achieve. And depending on the frequency, the SAW and the BAW filter can be hard competitor. Usually, the SAW filter are used at low frequency. This technology is based on the acoustic wave traveling on the surface of the piezoelectric. And the distance between the transducer that we can find is inversely proportional to the frequency. And when we came to in high performance and high frequency, interference issue can occur, and the SAW filter became less performant. So the BAW filter became a better choice. And this one is based on the acoustic waves that travel in the piezoelectric deposited on acoustic reflector. So at System Plus Consulting, we published 3 reports yet, and the 4th is coming on advanced filter and packaging in RF mobile application. And to begin with, we will go through Murata's SAW filter, the next report, and after we will see BAW filter from Broadcom and Qorvo. So in the SAW filter industry, the technology is well known, but some improvements are still made to enhance the performance of the filter. And in some cases, the SAW filter can even compete with the BAW filter. The manufacturing over the year are still the same. It's a classical thin film deposition. But one of the major innovation by Murata this year, the past year, is TC-SAW for a temperature compensated filter. And to get a cost-effective filter, the choice of Murata was to use a protective layer on the IDT, the transducer. And we can see that for a duplexer, study shows that the cost of the dies is balanced with the backend process, and it's very how do you say? It's quite low priced. And according to Murata estimation, they are still in course, and they follow the 4G's smartphone evolution with at least 1 Murata's units per 4G's smartphone. So to continue, I will talk about the BAW filter now. Here we have the Broadcom and Qorvo are in competition, and they use 2 kinds of technology based on the same physical process. For Broadcom, we have a technology called FBAR for film bulk acoustic resonator, and it uses a cavity that we deposit above a piezoelectric, usually aluminum nitride, and this piezoelectric will vibrate on the air cavity. And the thickness of the structure will depend on the frequency that we want to use. Secondly, we have the technology used by Corvo called SMR for solidly mounted resonator. And like the other, the piezoelectric is deposited between two electrodes. But here under the structure, we have that we call a Bragg mirror. And usually it's realized with several layers, typically tungsten and silicon oxide. And the similarity between the two technologies is also that the mirror and the cavity is used to keep the wave inside the piezoelectric. So to go through the two technology, I will present the two of them face to face. It will help us to understand the difference and the advantage of both. We retrieve here the major difference between the two. Broadcom has to realize a micro-machining process to create that we call the swimming pool, so the air cavity under the piezoelectric. And it's very close to a MEMS process, whereas Corvo simply use a classical process with thin film deposition. And during this year, System Plus Consulting has conducted 2 reverse costing on Broadcom FEM, and we show that even between the 8030 found in iPhone 6s Plus and the 9040 found on the Samsung Galaxy S7, that is very, very close in time, we have quite a huge development. We were able to show that the Broadcom has chose a new way that's adding scandium for doping is piezoelectric to enhance the F-bar performance. So innovation in this technology is still in progress. Another challenge in the RF mobile module is the packaging. And to prevent any influence of the environment, the temperature, the humidity, the filter have to be sealed from the outside. And between the two actors, we can find 2 ways to seal the cavity. For Broadcom, we still have the micro-machining process that realizes the shape of the sealing frame that we can see. And we have also a metal bonding with gold that seals the cavity. We can see here the package module molding outside the filter. Corvo keep the thin film deposition to create the protective cavity on the filter. It used a UV sensitive polymer laminated that with some deposition and bake process realized the shape that we can see on the same view. And the other challenge is to connect the filter to the FEM PCB by keeping the smallest footprint. And here we have also 2 different kind of choice. For Broadcom, we retrieved the micro-machining process by using TSV through silicon via to redistribute the filter in-out at the bottom of the filter. Doing so, they have managed to have a very small filter. But Corvo has chose to use a copper pillar that give him a better thermal management compared to the Broadcom. And after the physical analysis that we have in the report, all information allow us to provide a cost estimation of the die. And in the repartition of the price, we have managed have two major behavior. For the two, the both filter has approximately the same part of the cost. But for Broadcom, the different choice in the packaging allow them to have a small die, which gives a smaller price per die. But with the repartition of the price, we can see that the two substrates required to make the cap and the bottom of the filter cost two times the price for the raw wafer cost of the Corvo. And finally, for the Corvo, the major price is in the cavity and the copper pillar manufacturing. So to conclude, I would say that System Plus is able to evaluate the cost of the filter now, and in the future we will present more and more evaluation in this field. For us, it's a new beginning. Thank you.
Thank you, Stéphane. So thank you all for this relevant and very interesting information. So we are now going to wrap up with the Q&A session. We will answer as many questions today as time permits and follow up with, via email on the remaining questions. So the first question is for Claire. So it's interesting to see the momentum in M&A operations in the RF industry. So maybe you can let us know what are the more the next M&A to expect.
Okay, this is a good question. So of course, yes, on the beginning of my talk, I showed you some examples of M&A to acquire some technology, some building blocks. I think originally, if you look at, for example, Qualcomm and Skyworks, so they had this idea of full integrations with all-in-one module. So really based on one platform. Well, since it's not so obvious anyway. So we've seen acquisitions, so Skyworks trying to get some filters technology, so the joint venture with Panasonic, Qualcomm again trying to get these filters, so this very important building block and going with joint venture with TDK Epcot. Of course, I think we can expect more joint venture and M&A in the future. From what we see, so we see more and more Qualcomm being very aggressively penetrating this RF industry and going also into from the baseband into more front-end module or things like that. So and of course it's a big player, so we could expect some big players like that trying to acquire more technology blocks from smaller companies or very let's say technology-rich companies. Maybe a CMOS power amplifier with some small companies which can handle this. I mean, it's very hard to predict what kind of M&A we can expect, but for sure, I'm pretty certain that this is not over. Okay, simple answer, but...
Oh, perfect. Thank you, Claire. Maybe a second question for you. How do you see the interface between all the different components developing to meet 5G? So assembly technologies, packages, substrates, and etc.
Oh, okay. So again, a tough question. It's a good one, and something maybe I didn't stress too much in my presentation, but 5G will really depend on the use cases. So of course, the moment the standards are not really well defined, it's quite unclear, so we can envisage for the really near future 5G more as an evolution. Well, so people might argue this will not be 5G, but more a 4G evolution, going to frequencies approaching the 6 gigahertz. So, and then you could consider 5G if you look at the more revolutionary side, so very high frequencies in this millimeter wave area. I think the pressure will really be at the assembly, so really at the packaging side, for sure, because with the miniaturization, as I said, the RF in a cellular has less and less space and has to cope with that. But the RF needs space to avoid crosstalks, insertion loss, and things like that. So I think we might see, and this is where I think the packaging is bringing a lot of innovation, and that's where I think we will also see more innovation in the future. Again, a general answer, but okay, I don't have my packaging experts with me, but that's a question we could answer with them.
Okay, thank you very much, Claire. Now a question for Dan. So I heard about GaN on silicon and GaN on silicon carbide. How do you compare them, and which one has the more potential?
Okay. Yes, GaN on silicon and GaN on silicon carbide. Yes. In fact, they are two competing technologies in GaN RF, which use different materials as substrates. Today, GaN on silicon carbide is more mature. It has been under R&D phase for a long time, and well, it's now coming to a rapid development period. In nowadays, most GaN implementations is with GaN on silicon carbide, and the silicon carbide has a better thermal conductivity. So in theory, the device performance is slightly higher than GaN on silicon devices. And while for the GaN on silicon, the advantage is that the silicon substrate is much cheaper, and they can be produced on 8-inch wafers. So because the price has been for a long time crucial for GaN. GaN on silicon has strong potential in lowering the price and perhaps increase the sales. For now, GaN on silicon carbide is the majority, but the future is still yet to be seen. It depends how the players work with system manufacturer, how they control the cost performance, and also the reliability issue. I don't want to do the advertising, but you can find more detailed comparison and analysis on our report GaN RF 2016.
Thank you. We have a second question for you. So,
okay.
Is there enough GaN wafer level manufacturing today to support the proposed increases you forecast?
Mm-hmm. Okay. Could you please, where could I have a backup for those kind of questions? Yes, as you can see on this slide, this is GaN RF foundry technology comparison. We can see that near the K and K band, there is a lot of players which is expanding their production line, and for now most of the GaN products are with 4 inches, and some of the market leaders already begins with 6 inch. So if we estimate that in the coming 5 years, the number of wafers will like double or triple, we think it's quite plausible.
Okay, thank you very much. Now, Stefan, two questions for you. So the first one would be, what is expected for SAW filter in the next few years with the emergence of 5G?
About this. I think SAW filter until now have a small innovation in the market, and I think for them it will still be open for the low band. In the old smartphone will still work on the GSM, on the UMTS, and 3G band. But for the 5G, I think the challenge will be very, very hard to get because of the limitation of the technology, because of the small distance between the transducer. So I think a lot of innovation will have to be made in this field.
Okay, thank you very much. So I guess we're quite over now, so the webcast is ending. Within the next 24 hours, you will receive an email that will include the recorded session. Please feel free to share the presentation with your colleagues in your organization who will benefit from the information that has been presented. And please make sure that you can find also our analysis and reports on imicronews.com that were presented today. Also, our team will attend the European Microwave Week event in London in October, so feel free to go there to meet them. So thank you for joining us today. Do not hesitate to contact us if you have any additional questions. You can find your appropriate Yole Development contacts by geographical area on the last slide of the presentation. So have a nice day and talk to you later. Bye.